we're starting out with intermediate value theorem, also known as IVT. And I need a reader. Thank you so much. Miller time, go.
If f is continuous on the closed interval,
Yeah.
where f of a doesn't equal f of b, and if k is any number between f of a and f of b, then there is at least one number c in a b, such as f of c equals k.
Very nice. All right. So this is our monkey in the middle theorem. This is one of the big theorems. We can abbreviate it as IVT for intermediate value theorem. But this is basically what it says. If the two y values are different, and I have a what kind of function? Continuous function. Then there's something in between. All right. At least once there's something in between. And this is called an existence theorem because it doesn't prove anything other than it exists. All right. And so anyway, we're not always solving for what k is or f of c, but it just tells us it's existing. So for instance, we have two y values. They're different here. And I have a continuous function. What does continuous mean again? Mathematically, what? The limit is equal to the value. All right. So we have a continuous function, and it means that something's going to be in between it at least one time. Now, in this one, it happened how many times? Three. It happened 3 times. However, it will at least happen one time. Now, if you look at the other thing, the two y values are different, so that's good. However, can we use IVT on this one? No, why not? It's not continuous. All right? So it doesn't mean there's always going to be that monkey in the middle. All right, let's put this thing into practice. I need to read it. Thanks, Trinity. Go for it.
Use the intermediate value theorem to show that the polynomial function f of x is equal to x squared plus 3x minus 2 has a 0 and then 0, 1.
All right, so it has a 0. So that's what I want to know. What is the 0 mean? F of c would equal what? 0. All right. So 0 has to be in between it. It doesn't have to be in the exact middle, but it has to be in between our two y values. Now, do we have our y values? No, we got to solve for it. And so to solve for it, we just substitute in our a and our b. In this case, our 0 and our 1. So what is f of 0? -2. And what is f of 1? 2. So, is 0 in between those two?
Yes.
Yes. So the way I write it is with an inequality. So now I have -2 is less than f of c, which is equal to 0, which is less than or equal to 2. And then I throw out my gang sign, intermediate value theorem. Now, this was a continuous function, so I was allowed to say it's going to happen by the intermediate value theorem. Now, did we actually solve for where it was 0? No, it just tells us it exists. All right. So if we have x as 0 and we have x as 1, yeah, it crossed at least one time. All right. In this case, it only did cross once, but it just tells us that it will cross 0. All right. Pretty good. All right. Let's keep moving. So now we're on to 1.5, infinite limits. Okay. When we have increasing or decreasing without bounds, it's said to be infinite limits, which means it keeps going up, up, up. That's increasing without bound. It's said to go down, down, down. That's decreasing without bound. Now, infinity is a long-term behavior. It's a direction. It's not a number. Even though we can kind of think of them as numbers sometimes, it is a direction. For instance, infinity means right or up. Okay? Depending on how you're talking about it. And negative infinity means left or down. All right? So I have this function. I got 3 over x minus 2 going on. Where's my problem area? 2. What's happening at 2? I have a vertical asymptote. What makes it a vertical asymptote at 2? A number over 0. All right. And so what I'm going to do when I get a vertical asymptote is I can find a limit a little bit from the left, and I can find a limit a little bit from the right. Now, this is our new technique today. We only go a little bit from the left and a little bit from the right when we have what? A vertical asymptote. Are you following me? If we get a 0 over 0, I get indeterminate form. Do I do this a little bit from the left and a little bit from the right thing? No. Okay, don't forget everything you've learned before here. All right? Just because you got a new tool in your toolbox doesn't mean you always use it. All right. So, if I do it from the left, what's a little bit left of 2? Like 1.99, right? And so I have a positive number, and if I substitute in 1.99 minus 2, I have a positive number over a really small what? Negative. Which makes it negative infinity. Which means from 2 from the left, it's going down. That's what that means. All right, if I do 2 from the right, that's a little bit more positive than 2. So I'd be like 2.001. I'd have a positive number over a really small what? Positive, which makes it positive infinity. All right, pretty good? All right, fantastic. So here we go. On vertical asymptotes, we must get a number over 0, then we can do a little bit from the left, a little bit from the right. So let's write this one out. We have a limit as x approaches 1 of 1 over x minus 1 squared. Well, what's a limit? We approach from both sides. What do we try to do first every time? Substitute in. What do we get?
Number of 0.
Number over 0. Oh. So now I can go a little bit from the left and a little bit from the right. All right. Now, does my limit exist when I get a number over 0? No, it doesn't exist. All right. Because it's going to increase or decrease without bound. All right, or both, or one of them, something. All right. However, I now can do a descriptor, basically saying, hey, it's going to go up to infinity. Hey, it's going to go down to negative infinity. That kind of thing. All right, but my limit doesn't truly exist. Because does infinity actually exist? No. All right, it's a direction. It's a descriptor. All right, so now we end up having a limit as x approaches 1 from the left of this function, and a limit as x approaches 1 from the right of this function. Well, if I do a little bit from the left, that'd be like what? 0.99. So 0.99 minus 1 is a really small what? Negative, but what happens? Squared. So I have a positive over a really small what? Which makes it positive infinity. And then, if I do it from the right, what do I get? A positive over a really small what? Positive, which makes it what? So, what's my limit? Positive infinity. All right. Now, if this is a free response question, you could either say positive infinity is the answer, or you could say it doesn't exist because it does what? It increases without bound. Now, if it's multiple choice and then infinity is an answer. Multiple choice and infinity is an answer choice. Guess what you want to pick? Infinity. All right, because that's a descriptor now. You following me? All right, we're moving. So this next one, I got negative 1 over x minus 1 as x approaches 1. So I substitute in, what happens? It breaks, number over 0. So now I need to go from a little bit from the left, a little bit from the right. So if I go a little bit from the left, I now have a negative number over a really small what? Negative. Which makes it what? Positive infinity. And then I go from a little bit to the right now. So 1 from the right. So I have a negative number over a really small what?
Positive.
So I end up with? Negative infinity. All right. So what this means is when I go from 1 from the left, it's going up. If I go 1 from the right, it is going down. All right, you see how that worked? All right. Now, truly, are we doing much math in terms of like working something out? No, but what are we doing? We're doing a little bit of thinking. You know what I'm saying? All right, it's not hard. It's just a different way of thinking. All right, so what this page is basically saying is, when do we get a vertical asymptote? Number over 0. And when do we get a whole? We get 0 over 0. When are we allowed to use this little bit from the left and a little bit from the right thing? Vertical asymptote. All right, if you get a whole, factor, rationalize, fraction thing. Okay, those are still your techniques that you go to. All right, here we go. Let's do these. So we're going to find all the vertical asymptotes, and we're going to kind of talk about the graphs of them. So the first one I have is 1 over 2 times x plus 1. Where's my problem area at? Negative 1. So I have a vertical asymptote at what? X equals negative 1. All right. Because I get a number over 0 when I substitute a negative 1, right? All right. So now I want to do a limit as x approaches negative 1 from the left. And I want to do a limit as x approaches negative 1 from the right. So if I go from the left, that's a little bit more negative than negative 1. So I get a positive number over a really small what? Negative, which makes it what? Negative infinity. And then if I do it from the right, it's a little bit more positive than negative 1. So now I have a positive 1 over a really small what? Positive, which makes it what? Positive infinity. So if we look, we got a vertical asymptote going on at negative 1. From the left, it goes down. From the right, it goes up. All right, pretty good? All right, let's do the next one. X squared plus 1 over x squared minus 1. What would I probably start off with? I'd F them up. I really would. All right, what would I F up that bottom to? X plus 1, x minus 1. All right. It's going to make your life a little easier. You could deal with it, but I think this is probably going to be easier. All right. So where are my vertical asymptotes at?
1 and negative 1.
X equals 1 and x equals
Negative.
negative 1. All right, we'll just deal with one of them. Which one do you want to deal with? Negative 1. Let's do negative 1 then. So now I'm just going to do limit as x approaches negative 1 from the left. And the limit as x approaches negative 1 from the right. All right. So if I substitute in negative 1 from the left, again, what am I going to get up top? I get a positive. But then I want a little bit more negative than negative 1. So this is going to be what? It's going to be negative. And then this is going to be what? Negative. Right? So it makes it a really small what? Positive. All right? So that goes to positive infinity. All right? And then I'm going to go negative 1 from the right. So it's a little bit more positive than negative 1. So like negative 0.99. So this is. So I get a really small what? I get a really small negative, which makes it what? Negative infinity. All right, and you do the same thing with 1 as well. All right, so if you look at this, if I do negative 1 from the left, it goes up. If I do negative 1 from the right, it's going down. All right, so that's how we would work with it. Cotangent x. how would I probably think of cotangent x? Good, cosine over sine. Love it. On your homework, you're going to get a secant. How would I highly suggest you work with a secant? 1 over cosine, okay? I really would work with it that way. Now, when am I going to have a vertical asymptote with this cotangent? Huh? 0 and pi, sure. So my vertical asymptotes are at x equals 0 and pi and 2 pi and 3 pi and so forth. All right, all my intervals of pi. All right. So let's just deal with 0. So now if I have a limit as x approaches 0 from the left, and I have a limit as x approaches 0 from the right of cotangent. Now, this is where I would kind of think of my unit circle. All right. This right here is 0, correct? All right. So if I go 0 from the left, that would be down here. Are you following me? Okay, it'd be like the negative part of 0. So I kind of think of it right there from the left, which means cosine would still be what? Cosine deals with dx, right? Cosine would be a big positive. You follow me? And sine would be a really small what?
Negative.
Negative. So a big positive of a really small negative would be what? Negative infinity. And then if I do 0 from the right, it's just a little bit more than 0. All right? So my cosine would still be what? Positive. Big positive. And then my sine would end up being what? A really small positive, which makes it go to positive infinity. All right? So when you deal with your secant one for your homework, you're going to get this negative pi over 2. And so when you do it, it's going to be kind of like there. Okay, cool. All right, so then when we graph it, if we did 0 from the left, go to negative infinity, 0 from the right, it would start going to positive infinity. Make sense? All right, cool. All right, we got one more before I set you free. So write this function out. I got x squared plus 2x minus 8 over x squared minus 4. I have these quadratics going on. What should I probably do with them? I'm going to F them up. That's right. So what does it F up to? X plus 4x minus 2. And then what does this x squared minus 4 thing do? X plus 2, x minus 2. Love it. What happens? I have a hole going on. Where is my hole? X equals 2. So I have a hole at 2. Ooh, what just happened there? How did I do that? I don't know what just happened. All right, I get a hole at 2 comma something. Now, how do I get that something? I substitute 2 into my simpler function. So now I end up having 6 over 4, and we usually call that what? 3 halves. So I have a hole going on at 2 comma 3 halves. Now, what else do I have going on? I have a vertical asymptote. Where is my vertical asymptote? X equals negative 2. Now, this could be a great kind of test question. What are my discontinuities? At where? X equals what? Negative 2 and 2. Okay? What's going on at negative 2? Is it removable or non-removable? How about 2? What about negative 4? Is that a discontinuity? No. Okay, don't be tricked. Okay, cool. All right, So we have our hole there, we have a vertical asymptote there. So now I want to figure out a little bit left of -2 and a little bit right of -2. Now, I personally would not keep the original function. I would think about the simpler function. Are you following me? All right. So if I do -2 from the left, that's a little bit more negative. So I get a what up top? Positive or negative? Positive over a really small what? Negative. So that goes to negative infinity. And then I have -2 from the right, so a little bit more positive than -2. So I get a positive over a really small positive, which makes it positive infinity. And so my little graph should look like this. All right, it goes down to negative infinity from the left, goes up to positive infinity. I got this hole. All right, pretty good? All right then. So I would like you to start your homework. Also on Canvas, there are 2 reviews. There's chapter 1 review and then extra practice review. I would highly suggest that you look at those and do some of them so we can go over some stuff on block day. All right. So then your test will be on Friday after that. All right.